So let's talk about determinants. If a matrix is a square matrix, okay, what that means is same number of rows and columns. That's what it means to be square. So if a matrix is a square matrix, then a number can be assigned to it called its determinant. It can be used to find the inverse of a matrix, which we'll learn about in the next lesson, 10.5. Or it can be used to solve a system of equations. So you really got to think. We've learned now a few different ways to solve systems of equations. We just learned in the last lesson how to solve using row echelon form and Gaussian elimination. We learned before that how to solve it using just normal elimination and substitution. We're going to learn another way to solve a system of equations called Cramer's rule, and it has to do with determinants.
Is it Cramer's or
Cramer's.
Cramer's?
Cramer's rule. Now, finding the determinant, it's pretty easy. It's just an algorithm. You have to remember what steps to go in, the order of the steps, and that sort of thing. But if you're familiar with the order and the steps, it's really not that hard to do. But just looking at it and practicing it one or two times, you're not going to get that algorithm really down. So you've got to make sure to get a lot of practice in. So let's start with 2 by 2.
Should this be an example?
No, we're going to talk about how to find the determinant first. So, if matrix A is that matrix right there, then, now there are a couple of different notations for determinant, and you've got to be familiar with all of them. The book may ask you to find this, D-E-T, and then put the capital letter A in parentheses. That means find the determinant. Okay. Or another notation is to have vertical bars like this. I know it resembles absolute value, but it's not the same as absolute value. This, in the world of matrices, this means find the determinant. Or you can take the original entries of the matrix and put those entries in these straight vertical bars. A, B, C, D. All of these notations mean find the determinant. Whatever notation you're given, you find the determinant the same way. For a 2 by 2, it's really easy. It takes about 5 seconds. You take A and multiply it with D. I'm talking about in the original matrix. You take A and multiply it with D, so AD, and then you minus B multiplied with C. was AD minus BC. That's how you find the determinant. So example. Find the determinant. It's pretty easy. What is it? Yeah. Take me through it. What do we do?
6 times 3.
6 times 3 minus 4 times 2. 18 minus 8 is 10. Determinant is 10. Okay, let's try another one. Okay, try that one. What'd you get, Gabe? Oh, I just assumed you were done with this one already. All right, walk me through it. Negative 3 times 12 minus 6 times negative 1. Negative 36 plus 6. Okay, here's a little review question for you. Find this. Find A times B. What's that? If a 2 by 2 matrix is multiplied with another 2 by 2 matrix, you're going to get a 2 by 2 matrix. A 2 by 2 matrix has 4 entries. All you do is just multiply corresponding entries together, right? 6 times negative 3, you get negative 18. Is that how you do this? No. No, no, no.
That is the first first step, you get the first quadrant, the first whatever that is.
If you want this entry right here,
The first thing to do is to multiply 6 by -3 and then 4 by -1.
you need this row and that column. 6 times -3 is -18. You add that to 4 times -1. Okay, to find the entry beneath that, you need the second row first column. So 2 times -3 is -6. You add that to 3 times -1, which is -3. Now to find this entry right here, this one is in the first row second column. So you need first row, second column. 6 times 6 is 36. Now you move across the column and down the row. So it's 4 times 12, so you add that to 48. Last entry here, second row, second column. Going across the row, down the column. 2 times 6 is 12. 3 times 12 is 36. So we have -22, -9. 12 plus 36, that's a 48 down here, and then 36 plus 48 is 84. Yeah. You guys ready for 3 by 3? It is significantly different than a 2 by 2. Let's go back one more time. How do you find the determinant of a 2 by 2? AD minus BC. Okay? Here we go.
Yay!
Okay. So let's just look at a general 3 by 3 matrix. A, B, C, D, E, F, G, H, I. So there are a couple of words here you have to, or we have to define. First one is called a cofactor. Okay. The cofactor of a matrix. It's an entry of the matrix. Any entry of a matrix can be what's called a cofactor, but it's not just the entry, it's an entry of the matrix multiplied with either 1 or -1. And you can't just say, well, I'm going to multiply this one by 1, that one by -1. It follows a particular pattern. For a 3 by 3, to determine whether you would multiply the entry with a +1 or a -1 to find the cofactor in that spot, you'd have to use this pattern here. Okay, so for example, you see where my pen is pointing, F?
Yes.
If I wanted to take this entry right here and turn it into a cofactor, I take this entry and times it by -1, and that's the cofactor. You following here? Okay, or what about this entry right here, D? You take the entry and multiply it by -1. Okay, so these are called cofactors. We good? The other word is called minor. So choosing a cofactor and then deleting the row and column containing that cofactor leaves what's called the minor matrix, or a minor matrix. There's more than one minor matrix within a matrix. What are we doing with this? We don't want that. So for example, if I chose this letter A as my cofactor, you following? I'm choosing the letter A as my cofactor. I need to cross out that column and I cross out that row. What's left over? So that's what's called a minor matrix. Okay, so for example, if A is chosen, as a cofactor, then the minor matrix is E, F, H, I. Well, technically, we need to add one more thing to this. Definition here. If I erase these bars and put these kind of bars, what's the difference? This is a determinant. Okay. A minor is not just the matrix left over; it's actually the determinant of that matrix that's left over. So if EFHI is the matrix that's left over, what's the determinant of that? EI minus HF. So the value of that matrix, the determinant of that matrix is called the minor. You're going to have to know all this in order to find the determinant of a 3x3 matrix. Okay. So here's the process. Rather than doing it with a general matrix, let's go to a specific one, and we'll go through the process. So example 2. Here we have a matrix A. First column is 2, 0, -2. Second column is 3, 2, 5. And the last column is -1, 4, 6. The directions are to find the determinant of A. So steps. Choose any row or column. And it does not matter, any row, any column. You can choose arbitrarily, you can close your eyes and put your pencil down and see what you end up on. You can just choose whichever one.
I have a question.
Yeah.
So if you choose the center one, and then do you just use the four corners? Like you use the center one and pass out the column, and then use the 4 corners instead?
As the minor? Yeah, if you cross out this one and that one, then it would be 2, negative 2, negative 1, 6. Yep. So choose any row, any column. Step 2, once you have chosen a row or a column, okay, you need to find the sum of the cofactors multiplied with the minors of that particular row or column. Not all of the cofactors and not all of the minors, just whatever row or column you've chosen. So I'm going to choose this top row right here, 2, 3, and negative 1. Okay. Now the first entry in that row is 2, but that's not necessarily the cofactor. You got to remember that little pattern here. We have plus, minus, plus, minus, plus, minus, and then plus, minus, plus. So if I'm choosing this entry, what's the cofactor?
2.
It's still going to be 2 because it's a positive number there. So 2 is the cofactor. Now you have to multiply that with the minor that's left over. So if I'm choosing 2 as my cofactor, remember you're going to cross out the row and the column containing that cofactor. Now I don't want to cross it out on here because it's going to get too messy, but if 2, 3, 3, negative 1, and 2, 0, negative 2 were crossed out, you'd be left with the determinant 2, 4, 5, and 6, right? Because we're finding the sum of the cofactor multiplied with the minors. Okay, but that's just the first cofactor multiplied with its minor. We need to move across the row now because we've just done it to the first one. So now move to the next entry. The entry is 3, but what's the cofactor? So we're going to minus 3 because that cofactor turns out to be a negative 3. And we multiply that now with the minor that's left over if we cross out the row and column containing that cofactor. So if this middle column is crossed out and the top column or row is crossed out, we're left with 0, negative 2, and then on the other side we're left with 4 and 6. Let me see if I can figure out a way to. What was that top row now? 2, 2, 3. Let me figure out a way to so I can lock this so I can write on it and then erase it. Hold on now. I think I gained. So, yeah, look at that.
Fancy stuff.
So let me illustrate. So if we're choosing 3 as a cofactor, you cross out the row and the column containing that cofactor, and what's left over? 0, negative 2, 4, and 6. So that's the minor right there. Okay. Now we move on, and we have to choose this number. Okay. But if that's the entry, what do I multiply that with to find the cofactor? Well, I multiply with this positive 1, so it still stays negative 1. But if you cross out the row and the column containing that cofactor, then the minor is 0, 2, negative 2, 5. So we have 2 times by that determinant. What's that determinant?
8. 2 times 6.
2 times 6 is 12. 12 minus 20 is negative 8. And then we minus 3 times the determinant of this matrix. Close. It's because it's 0 minus negative 8, which is positive 8. And then we subtract 1 times this determinant, which is 0 minus negative 4, which is 4. So we get negative 16, minus 24, minus 4, which is negative 44. Now the reason step 1 says to choose any row or column is you would get the same value, negative 44, regardless of the row or column you choose to expand on your. It's always going to, the determinant of this matrix is negative 44, no matter how you find the determinant. Okay?
It feels like it's a puzzle, like someone just said.
It has a lot of uses, this determinant. Cramer's rule is one of them. It's not just some random algorithm that generates a specific number.
What
Now,
does the determinant do?
it helps you, well, in lesson 10.5, which we're going to get to next time, it talks about finding the inverse. You have to use the determinant to find the inverse of a matrix. You have to use the determinant for Cramer's rule, which solves a system of equations. So it is useful. Now, let's do the same problem using this row, or sorry, this column. Not just to prove that any row or column would work, but this column in particular contains 0 as one of its entries. Why would it be such a good idea? Why would it be such a good idea to choose a row or a column that contains a 0 as one of its entries? If we use 0 as a cofactor, wouldn't that eliminate one entire piece of this? Because 0 times any minor is going to be 0. So even though step 1 says choose any row or column, okay, especially one containing 0. That's just going to make the process a little bit shorter. So let's do it one more time. If I choose 2 as a cofactor, or as an entry, the cofactor from that entry is still going to be 2. The minor that's left over, if you cross out the row and the column containing 2, you still have 2, 4, 5, and a 6. Now we're using this first column, so move down to the next entry. If 0, yeah. Because we're choosing a new column this time. Instead of expanding across the top row, we're going to go down the column. You can do any row or any column. So if 0 is the entry, what's the cofactor? It would be minus 0. But if you cross out the row and the column containing 0, 3, negative 1, 5, and 6. But you guys, this is going to be a determinant. It's just a number. What's that number times 0? So this is just going to disappear. We don't really need to worry about that one, because that product's going to be 0. So now move on to the last entry of that column. Negative 2 is the entry, but what's the cofactor? It's negative 2 times this positive 1. So it's still negative 2. And if that row and column are crossed out, you get 3, negative 1, 2, and 4. So let's figure this out here. This cofactor multiplied by that minor is 2 times negative 8. This middle product reduces to 0, so we don't need to worry about that middle product. But over here we have negative 2 multiplied by 14. So it's negative 16 minus 28, which is negative 44. Okay, here's one for you. Example 3. Try this one. Find the determinant. here's your matrix. 4, -2, 4, 1, -1, 0, 0, 1, 3. How many, just by raise of hands, how many chose the first row? Did anybody choose anything other than the top row here? Middle column? Middle row? There's no zeros in there. Alright, we can do this middle row.
Yeah, that's what I did.
Or middle column, yeah, let's do this middle column. So, if this middle column was chosen to expand, then what's this first cofactor going to be? -1. And if you cross out, ooh, hold on. Let's see if this works. So if you cross out the row and column, then you have -2, 4, 1, 3. Okay? That is cool. Now, we're choosing this as a cofactor, or as an entry. What's the cofactor that we'd have to... We'd multiply with positive, so it still stays -1. So it's -1. So if that row and column are crossed out, you have 4, 4, 0, 3. Now we choose 0, but 0 multiplied by any minor is going to be 0. So it's -1 times whatever this determinant turns out to be. And it's -6 minus 4, which is -10. And then we subtract 1. This is going to be 12 minus 0, which is 12. So we have 10 minus 12, which is -2. Now, hey, just meeting with the department this Monday, even though calculators aren't allowed, hopefully all of you next year are going to sign up for AP Calculus or some kind of a calculus course where you are going to be able to use calculators, so you need to know a little bit about them. So with matrices, there's a lot you can do on a graphing calculator with a matrix. Okay? Do you see above where my mouse is pointing? Do you see how it says matrix? I know it's kind of hard to see. Let me see if I can make this bigger. Yeah, it doesn't go much. Do you see right above where I'm pointing it says matrix? If you hit second and then there, it brings you to the matrix menu. Okay? And then I'm going to edit matrix A. If you go to the edit menu of matrix A, it allows you to type in entries into that matrix. So hit enter. Right now matrix A is defined to be a 1 by 1. I want to change that to a 3 by 3. Now I can type in the entries of that 3 by 3. So I'm going to type in this matrix right here. So 4 and then hit enter. Then it just moves across 4, 1, 0, and then -2, -1, 1, and then 4, 0, 3. That's matrix A, right? So now hit second and then quit. It'll bring you out of that menu. Go back into the matrix menu. Now it says matrix A is the 3 by 3 we just typed in. Is that correct? Go over to this math submenu. Do you see how it says DET? That's the determinant. So hit enter, and then it asks for which matrix do you want to find the determinant of. So go back into the matrix menu, click on A, close your parenthesis, hit enter, and it gives you the determinant. Okay, pretty quick. So, you know this example we did at the beginning of class right here? You see the one I'm pointing at? Okay, check this out. Go into your matrix menu. Go over to edit. I'm going to call matrix A a 3x4 matrix now, and I'm going to type in the entries of that matrix we had there. Tell me what they are. 1, 4, -2, -3, 2, -1, 5, 12, 8, 5, 11, and 4. Okay.
That matrix right down for us.
The matrix that we did at the beginning of class, this one here. So, if you go into the matrix menu and then go to math and scroll down, do you see this REF? What do you think that stands for?
Refrain.
Row, echelon. It stands for row echelon form.
Do you like our ideas? We're pretty creative.
You accidentally deleted row echelon.
I think I might have. Hold on.
You deleted it.
This kind of takes a while, but I guess it's easier than doing it on paper.
So row echelon form of matrix A.
Well, that's complicated.
It doesn't fit all on the screen, but if you look at that bottom row, what is this bottom row telling you? 0, 0, 0, and then it has a 1 at the end of that row. What does it tell you?
Then Z equals.
It has 0, 0, 0, and then a 1, which means what? Does 0 equal 1? So what do you say here? No solution. Isn't that what we determined by hand? Okay. So you can use these calculators for row echelon form, for determinants. Yeah. You can find row echelon form different ways. Okay. Yeah, I'll give you the same thing. This did different row operations than we did here, but it ends up at the same. All right, so anyway, it is useful to know how to use these for your AP class next year. Your AP Calc class.
Because we're all taking calculus, everyone.
It doesn't matter which one's easier, because it will get you out of more credits in college. Let's do Cramer's rule. So, Cramer's rule uses determinants to solve a system it uses determinants to solve a system of equations. So in general, if we have ax plus by equals r, and cx plus dy is equal to s, these are just arbitrary letters. So here's the process of Cramer's rule. You have to find a couple of determinants. The first determinant, capital D, is equal to the determinant. Come on, you guys, control yourself. I know it's hard, but control yourself. The first determinant is the determinant of a matrix comprised of the coefficients of the variables. So that's going to be A, B, C, and D. That's the first determinant you find. What is that determinant, by the way?
Or AD minus BC.
AD minus BC. The next determinant is going to be a capital D, but I'm going to put a subscript of X by it. D sub X. That determinant is a little different than the one you just found. The subscript of X means the entries in the X column aren't going to be A and C anymore. You're going to replace those entries
With X.
with R and S. So R and S go in the X column. The Y column has the same entries of B and D. That's the determinant you find there. So what's that determinant?
RD minus BS.
RD minus BS. Okay, next determinant is D with the subscript of Y. Now you got to pay attention to the subscript. Now, since the subscript is Y, the second column takes on those values of R and S. So I'm going to put the R and the S here in the second column, because that's the Y column, right? The X column retains the original values as in the original system of equations. So you're going to put an A and a C. That determinant is AS minus CR.
Wait, why is it? I guess not.
Multiplication's commutative. So according to Cramer's rule now, once you have all three of these determinants, the value for X and the value for Y, because isn't that what we're solving for in a system of equations, X and Y?
Yeah.
The value of X and Y can be found simply by dividing these determinants. X is the determinant D sub X divided by the determinant D, and the value for Y is D subscript Y divided by D. This method can actually go pretty quick, especially if you're good at finding determinants. You can solve a system of equations using Cramer's rule pretty quickly. You have all this written down?
Yes.
Not quite.
Good question. So would that be like a two square?
This is two equations, two variables, but this can work with any size. You just have to have another determinant D sub Z if you have three equations. So here we go. Example 3. Or maybe this is 4. This is example 4. Solve this system of equations. 2x plus 6y equals -1. And then x plus 8y equals 2. Solve using Cramer's rule. If on a test, you guys, it says solve using a particular method, you have to use that method. Even if you solve it another way and get the answer right, I'm not going to give you credit for it. Okay? So this one is specifically solve using Cramer's rule. So what we need are those three determinants, D, and then we need D sub X, and then we need D sub Y. So how do we find D? Where do we get the entries for that matrix? Just the coefficients. Just the coefficients, not the numbers on the after the equal sign. So we're going to have a 2, a 1, a 6, and an 8. So what is that determinant? 16 minus 6, which is 10. Okay. Now we move on. D subscript X. The subscript says the X column, which is the first column, gets replaced with what? Say it again. -1 and 2 now go in place of the X column. The Y column here stays 6 and 8. So now we have to find that determinant. That's -8 minus 12, which is negative 20. The last one, d sub y, the subscript of y means that the negative 1 and the 2 go in the y column. So negative 1 and 2 go right here. The x column stays the same as it originally was, 2, 1. So this turns into 4 minus negative 1, which is 5. So Cramer's rule says your value for x is d sub x divided by d. Negative 20 over 10. To negative 2. Your value for y is d sub y over d. So it's 5 over 10, which is 1/2. So your solution is negative 2 comma 1/2. So I don't know, I know it seems a little bit slower now because you're just learning it, but if you get good at this, it might even be faster than the elimination method or the substitution method, because it's just finding a bunch of determinants. Okay? It does not only just apply to a 2x2 system of 2 equations and 2 variables. You can extend this to a 3 equation, 3 variables, 4 equations, 4 variables. It does become a little bit more labor intensive because you're having to use determinants of a 3x3 matrix. Oh, we're going to.
No.
Try this one, though, on your own. That's part A. Try part B. New system here. (6x plus 12y) equals 33. 4x plus 7y equals 20. Are we getting similar answers? 1/2 comma 2 with a burp. I don't know what the answer is. I haven't finished it yet. 1 and 1/2. 1 and 1. So 3 halves. So you got 3 halves comma 2. You got 3 halves comma 2. Anybody else? 3 halves comma 2. Because it's winter. It takes a long time to heat up this room. Well, this first one wasn't so bad, I hope. What was the determinant? 42 minus 48, so that's... Okay, so that one's not so bad. Oh, man. This one, maybe so bad, huh? 33 times 7. Now, I want to talk to you guys real quick. Hey, shh, 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 shh. Put your pencils down. Everybody put your pencils down. What if you were asked to do 33 times 7 in your head, without pencils, without paper.
I would do, is that what you're saying? Like, I would do 3 times 7 and 3 times 7 and then add the 2 middle numbers. That makes sense.
3 times 7 and 3 times 7.
And then add the 2 middle numbers so that it's 2, 3, 1.
I know, I do 30 times 7. You can stack it.
You do 21 and then you do plus 2.
What about this problem? Would this be easier to do?
Yeah.
In your head? Isn't that the same problem? Is that what a lot of you were saying?
30 times 7 and another.
What is 30 times 7? 210. 3 times 7 is 21, so 210 plus 21 is what? 231. So 231 minus 12 times 20. Hey. Focus, you guys. 12 times 20. What's an easy way of doing that one in your head?
12 times 2 out of 0.
20 times 10, 20 times 2, or 20 times 2,
I had 2 times 12.
add the 0. What about 12 times 10? What's 12 times 10?
120.
Then you can times that one by 2. So anyway, I mean, there's a lot of ways you can do some simple mental math, but it's 231 minus 240. That turns out to be negative 9. Okay, D subscript Y, we have 6 times 20. What's that one? 120 minus 4 times 33. That's 132. That turns out to be negative 12. So x is dx over d, which is negative 9 over negative 6, which is 3/2. Y is equal to dy over d, negative 12 over negative 6, which is 2. So the answer is 3/2, comma 2. All right, last one, then we're done. We'll put a fork in it.
You just sounded like Brian.
Really?
Have you heard his besides
Yeah.
Example 5, not
Example 5. You're going to love this one.
Like how it should have been made and all that fun stuff.
I do.
We should do that again.
We don't have time. Solve using Cramer's rule. Ooh, you're going to love this one. Oh.
Sorry, I just felt like I had to do that. There's no why.
Now, I haven't shown you an example of a 3x3 system of equations, but it's a natural extension. If you have a d sub x and a d sub y, because there's only an x and y variable, what happens when you have a z variable? You have a d sub z. And then how do you find the value of z? It's d sub z over d. It's just an extension of what we just did. And what's the nice thing about this going to be? I know it seems longer, but what do we have here in these rows and columns? A bunch of zeros. Okay? So finding these determinants is not going to be that bad. Yeah.
So for just the B, when you're trying to determine that one, you do 3 columns.
Yeah, so now each determinant is going to be a 3x3 determinant.
My brain hurts.
So take a second. Alright. Let's move fast here.
You know what process you have to.
Everybody stop for a sec. Stop. Freeze. Look up here at the screen. Come on up. The D sub x matrix, you have to take these entries after the equal sign and replace them in the x column, right? But in doing so, you have a column with 2 zeros in it. So when you're choosing to find the determinant, which column are you going to choose? The one with 2 zeros in it. Okay? So when you're finding this determinant, you choose this cofactor, but if 11 is the entry, what's the cofactor for it? Negative 11. Okay? And then the cofactor from that, if you cross out the row and the column, is going to be negative 1, 2, 2, 0. So you get negative 11 times 0 minus 4, which is negative 4. So that D sub x is 44. Now, aren't you going to have to use the same column 0, 11, 0 in every other matrix? It's just going to shift over one time. So use that column every single time.
Hey, TikTok, you're gonna roll. Yes. I win.
Can't we just shift the diagonal?
So what's D sub y going to be? It's going to be 1, 3, negative 1, 0, 11, 0. And then 2, 1, 0. Yeah. Possibly. So if you choose this middle column now, what's the cofactor now where the 11 is in its spot right here? What's the cofactor? Come on, you guys. We got to hurry. It's 11. Okay. Now we've got to figure out what the minor matrix is. It's 1, negative 1, 2, 0. So we're going to get 11, and then it's 0 minus negative 2. 0 minus negative 2. Just 2. So that one is 22. Now for D sub z, you're going to have the 0, 11, and the 0 in the last column. We have 1, 3, negative 1, and negative 1, 0, 2. If you choose that last column now, this 11, the cofactor from that entry is going to be negative 11. If you cross out the row and column, you're going to have 1, negative 1, negative 1, and 2. So it gets negative 11 times 2 minus negative 1, which is 3. So that equals negative 33. And just for sake of time, was anybody able to find out the determinant of just normal D? It was 11. Okay. Well, now this can be pretty easy. X equals dx over d, which is 44 over 11. So x equals 4. Hold on. Y equals dy over d. So that's 22 over 11, which is 2. And z equals dz over d, which is negative 33 over 11.
Those negatives would have canceled out, and it would have subtracted from the 2 instead of adding to it.
It is 1. It's not 1.
I'll tell you.
Because negative 1 times negative 1 is 1 minus 2 minus 1 is...
Here you get 2, right? From this cross product you get 2.
Right, and then from the negative is 1, so minus 1.
That's 2 minus 1. Oh yeah, so that's 1. You are right, so that's negative 11. So that's negative 11, and here we get negative 1. That's right. Hey!